Identify the components of the chromatography system. Stationary phase. The filter paper, which is explicitly described as moderately polar. Mobile phase, solvent hexane, C6H14, as shown in the diagram. Hexane is a symmetrical hydrocarbon containing only carbon-carbon and carbon-hydrogen single bonds, making it highly nonpolar. Apply the principle of competitive intermolecular forces, like dissolves like paper chromatography separates mixtures based on the relative attraction of the analytes to the stationary phase versus the mobile phase. Nonpolar molecules will have stronger London dispersion forces with the nonpolar hexane mobile phase. They will dissolve readily in the moving solvent and travel quickly up the paper. Polar molecules will form stronger dipole-dipole or hydrogen bonding interactions with the polar paper stationary phase. They will adhere to the paper, adsorb, more strongly, resisting the flow of the solvent and traveling much slower. Analyze the positions of the separated components after 30 minutes. Component X has traveled a greater distance up the paper, remaining closer to the solvent front. This indicates that X has a higher affinity for and solubility in the nonpolar hexane solvent, meaning X is relatively nonpolar. Component Y has traveled a much shorter distance, remaining closer to the origin. This indicates that Y has a stronger affinity for the polar paper, meaning Y is relatively polar. Conclude the relative polarities. Because component Y has a stronger interaction with the polar stationary phase than component X, Y is more polar than X, which confirms option D is the correct answer. The correct answer is option D. Y is more polar than X.